In the previous presentation, we had discussion on the current divider rule. Now in this video lecture, we will be talking about, or we will be discussing another example which is related to the current divider rules, in which we have three resistors which are connected in parallel, because the one end of these three resistors is connected to this point and the other end of these three resistors is connected to this point. And here we have two voltage sources. The first voltage source is connected to this point and the second voltage source is connected to this point. So for any electronic circuit, this hole will represent a DC voltage source. Now if the value of this DC voltage source is positive, so it means that the positive side of this DC voltage source is connected to this point and the negative side will be connected to the other point. Now in this side we have a negative valued voltage source. So by this negative sign, we means that the negative side of this DC voltage source is connected to this point and the positive side will be connected to the other point of this network. Now in this question, we are asked to find out the current IS through this parallel circuit and the current I1 through this third resistor and the power absorbed by this third resistor. Now let's consider if this point represents point A and this whole portion represents another point which is point B. Now let's redraw this network in a more simpler way. So if we have this point which represents the point A and this point or this line represent this point B. So this resistor is connected between point A and B. So R1 is connected between point A and B and R2 is already connected between point A and B, and R3 is also connected between point A and B. Now the positive side of this DC voltage source is connected to point A. The positive side of this DC voltage source is connected to point A and the negative side is connected to the other point. Now for this DC voltage source, the negative side of this DC voltage source is connected to point B and the positive side of this DC voltage source is connected to another point, or these two are connected in series. Now this is the R1, this is R2 and this is R3, and this source represents E1 and this is the source E2. Now to find out the equivalent resistance of these three resistors, so we already know that 1 divided by RT will be equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Now 1 divided by RT will be equals to 1 divided by R1 which is 12 ohms plus 1 divided by R2 which is 8 ohms plus 1 divided by R3 which is 4 ohms. Now the equivalent resistance 1 divided by RT will be equals to 11 divided by 24 ohms. Now the equivalent resistance from this equation will be equals to 24 divided by 11 which will be equals to 22.182 ohms. So the equivalent resistance of this network is equals to 2.182 ohms. Now as these two sources are connected in series with the same polarities, by the same polarities we mean that the current is entering for both the cases at the negative side and leaving the positive side. So the equivalent of these two sources will be, let's say E is the equivalent of these two sources, so E will be equals to E1 plus E2. So E1 in this case we have which is 12 volts plus E2 is 8 volts. So the equivalent of these two sources will be 20 volts. Now we can redraw this network as the equivalent resistor which is connected, while this E represents the equivalent of these two voltage sources and this resistor represents the RT, or the equivalent resistance of this parallel network. And here we have a current IS from this DC voltage source. Now to find out the current IS from this network by using Ohm's law, IS will be equals to E divided by RT. So E in this case we have which is 20 volts divided by RT is 2.182. Now the current IS through this parallel network will be equals to 9.166 ampere. So here we have 9.166 ampere of current through this parallel network. Now to find out the current I1 through this third resistor, so by using a current divider rule, I1 will be equals to ISRT divided by R3. So IS we already have, which is 9.166 into the equivalent resistance of this parallel network is 2.182 ohms divided by the resistance value of this third resistor is 4 ohms. So the current I1 through this third resistor will be equals to 5 ampere. So here we have 5 ampere of current from this third resistor. Now in order to find out the power absorbed by this third resistor, P3 will be equals to I1 square into R3. So I1 we already have, which is 5 ampere whole square into R3, which is 4 ohms. So the total power which is absorbed by this third resistor is equals to, so P3 will be equals to 100 watt. So here we have 100 watt of total power absorbed by this third resistor. So it's all for today's presentation. If you have any doubt, ask in the comment section. See you in the next one.